So Unit 7 for us, Lesson 2. So arithmetic sequences. So we've talked about in the first lesson that we're dealing with patterns that are two types, arithmetic and geometric. Arithmetic's the constant adding, and we said yes, they can subtract. We just call that adding a negative to stay consistent with just adding. Okay, and then geometric's multiplication. So today we're looking at the two arithmetic lessons 2 and 3. We'll just keep this video to lesson 2. So arithmetic sequence is a sequence in which each term is formed by proceeding adding a constant, a positive or negative. Just said that. Complete the following sequence. So you can see this one is 7, 10, 13, 16. Each term is determined by adding, you guys can see it's a 3. You can figure this out, which is called the common difference, by going I don't want to say second term. You can do second term, but the next term by the previous term, like every time. So term 2 by term 1, term 4 by term 3. You can do that every time. The difference of those gets you the common difference for ones that are arithmetic sequences. So term 2 minus term 3 is 10 minus 7, so 3. Then you have 13 minus 10, 3. And then you have 16 minus 13, 3. So it's just the idea that they're going to be consistent because it's constant. It's changing the same way. Okay, so the common difference for that quick example is simply 3. Okay. So find the common difference. So that's one of the things you're going to have to be able to do. And we use algebra a lot. We use a lot of solving to find things we're missing in this in these setups. You'll see what I'm saying as we go. But again, find the common difference. You simply can. This means a current term subtract previous term. That's what n minus 1 means. A lot of people struggle with the subscripts of when things are in variables. You need to kind of think about what it's trying to tell you. So what it's trying to tell you is, like, if you struggle with the variables, think about what it would be if it was numbers. So like if I said, if my number was 10, or t turns term 7, well, what's 7 minus 1? Term 6, right? So it's saying term minus previous term. That's what n minus 1 is, previous term. Will get you the common difference, okay? And that's from any location, okay? Okay, so same one now, they're just flipping it. So the common difference went from 3 to negative 3, right? It's going down by 3 every time. Okay. Now, there's a lot of them you can see right away, right? You guys are all pretty good with your mental math and your counting and whatnot. 16 to 13, 10. That was probably, shouldn't have said that. Open the doors for a lot of bad answers. Okay, I'm not good at counting. Okay, dang it. Sorry. Stop looking at me. I'm not talking about you. Okay, so for each of the following, determine which sequence are arithmetic and find their common difference. So to figure out if they're arithmetic or not, they have to have a constant change for every spot. So if it goes plus 2, plus 4, plus 6, that's not arithmetic, okay? Because it's changing the value each time. You see what I'm saying? Even though it's a pattern of even numbers, that's not consistent, okay? So let's go ahead and look here. So how you can check really quickly. 4 minus 2, 2. 6 minus 4, 2. 8 minus 6, 2. Yes, this one is arithmetic. So put an A. The common difference is 2. It's positive 2, yeah, it's going up. Okay. Okay, so you can kind of see this one with fractions here. 1/2, 1/4, 1/8, 1/16. That is getting smaller. So is it being subtracted? Well, it's not, because you can see that, like, for example, if I wrote as a common denominator and I went 1/4 minus 2/4, common denominator, 1/4 minus 2/4, that's a negative 1/4. So it went down by a 1/4 there. Okay? So from term 2 to term 1 went down by a 1/4. Well, let's do term 3 to term 2. So if I went 1/8 minus 1/4, well, 1/4 in terms of eighths is 2/8. 1 minus 2, I get negative 1/8 right there. That's a problem. I subtracted 2 minus 1 and 3 minus 2, and I got two different numbers. It's not arithmetic. Okay? It's not arithmetic. So you would just say, this one's not. Just not arithmetic. So that's all you'd say for that one. So not arithmetic. Negative 10, negative 4, 6, and 8. So work on your negatives here. Negative 4 minus a negative 10 means plus 10. So it's 6. 2 minus a negative 4, 6. 8 minus 2 is also 6, so it's good. Yes, arithmetic with a common difference of 6. Okay, D, you can see it's doubling here, so you kind of see it's not going to be arithmetic again. You have 8 minus 4 here for 4, 16 minus 8, 8, 32 minus 16, 16, so no, not arithmetic here. Okay. All right. In arithmetic sequence, we often use the following terminology. The first term in arithmetic sequence is represented by T1 or A. Okay? These are important values for the pattern. The starting point, term 1 or A, and then the common difference is represented by D. All right. Let's pretty much get some examples now. You're going to see where the solving and stuff comes from. State the values of A and D here. So state the values of A and D. So what is A? Negative 8. It's the first term. And what is it going up by? Good, 10. 2 minus a negative 8 is 10. 12 minus 2 is 10. 22 minus 12 is also 10. So quick check there. 10 is your D. Okay. Next one. A, 15. D, negative 5. Okay, so now we're going to develop the formula for the general term. And the general term is helpful because if I told you to find the 112th term, I don't want you to do 112 terms out in your paper. We can find that algebraically where we don't have to write them all out. Okay? Some people keep asking, well, if you say term 10 and I see the pattern 10 times at work, and I say, yeah, they're like, oh, okay. But I don't want you to do that. Okay? Because that's a little bit time-consuming, 1. And 2, it's actually not needed. We looked at those. Remember on lesson 1? We plotted the points for arithmetic. What do those graphs look like? They're linear. So you're just solving a linear equation. Okay? And we can do that. We feel pretty good about that. So anyways, let's go ahead and do this here, and I'll show you what I'm saying. So state the following. So term 1 is 2. Term 2 of 22, 32, 42. So A was 2, and the common difference is 10. Okay? So we're developing the pattern in terms of the calculation on the left and in terms of values related to A and D on the right. So like, what are we doing to A and D? Okay? So, for example, term 1 is simply 2. Term 1 is equal to A. Right? We call A the first term. Okay? Term 2. Term 2 is 2 plus 1 times 10 equals the 12. So 1 times the D. So term 2, A plus 1D. For term 3, 2 plus 2 times D equals 22, so A plus 2D, and you just see this pattern continue. 2 plus 3 times 10 equals 32. What's that? Yeah, I'm just going to fill all these out for the general term. Yep. Term 5, 2 plus 4 times 10 equals 42. A plus 4D. Term 30. Term 30 would be what? 29. Good. 2 plus 29 times 10 equals 292. Okay, so term 30 is simply A plus 29D. So how can I write that in a general term? So that means no numbers. Like, what's the pattern we're seeing? So let's do it with the D and the A in there. So the A will be 2 plus, how I represent 29? How are we getting 29? Take 1 off the term. And so what number or what letter represents the term number? N. So it's N minus 1 D, which is 10 for us in this part. Like that. So for that one, for the one we're doing right there, the general is 2 plus n minus 1 times 10. And then more general, so no all letters. so this is the actual one we're going to use all the time, is going to be a plus n minus 1 times d. That's the general term of an arithmetic sequence. And they're written there below. All right, let's do a few examples here. Good? Okay, so there they are. Consider the arithmetic sequence -6, -1, 4, 9. Term the formula for the general term of the sequence. So term the formula of the general term. So we're trying to figure out what it would be with a and d in there. So a we need first. A is -6, and what's it going up by? 5. So your common difference is 5. So your general term would simply be this. T sub n would be -6 plus n minus 1 times 5. That's your general term. What's that? Because it's always 1 back. The reason it is that is because we start with the 1 right here. So we're always going to be 1 more than we need because of the start in terms of why we do n minus 1. For the general term, yeah. It's always n minus 1 for the pattern. Because the reason is because that we set up the first term being a. So we need, if I put a 1 in here, that makes 0, right? And then, but that's what it should be. The first term should be this number here. And so it's kind of, by putting in a into the form, you need to move it back 1. So we minus 1, yes. But it'll be like that every time. So now, as I said, I don't want you to write the 12 terms out. You just plug in 12 for n and calculate now. It says term the value of the 12th term. So we go -6 plus 12 minus 1 times 5. So 12 minus 1 is 11. 11 times 5 is 55. Minus 6 is 49. So 49 is T12, term 12. Okay, any questions? Okay. All right, let's do another one. Then we're going to talk about arithmetic means. Okay, so this one says here, find the number of terms in the arithmetic sequence, 3, -1, -5, all the way up to -117. So this is where you have to use your algebra a little bit. So what it's saying is, my pattern goes like this for the first 3, and then we don't know what's in between, and it stops at -117. They want to know what term number that is. So you're solving for n. Okay, we're solving for n. Okay, now, could you guess and check? Sure, but that, again, we shouldn't need to be able to do that. What you're going to do is you're going to say, okay, I'm trying to figure out T sub n. Okay, so I'm trying to figure out what this number is. Okay, but I know the output. I don't know the n, but I know the output's -117, right? I know the output of that number that I don't know is -117, so we write it like this. Okay, we know what's a, 3, and what's d? -4, good. So, look, this is how you're going to write it. Because here's the normal. People get confused in this part, so please pay attention. It's not as hard as people think. Do you guys see that we know everything but n? When I say I mean everything. T sub n, a, d. The only thing that's missing is n. And that's what we're going to solve for. Okay? So we're going to go -117 for T sub n. We're going to put 3 here. We don't know n. And we know this is -4. And now we solve. So what would you do first to solve? Subtract the 3. So -120 equals, I'm going to write the -4 in front so you can see it, but it's just this, right? So now what would you do? I would divide the -4. I wouldn't distribute. I'd divide the -4 now. -120 divided by -4 is 30. Add 1. You have your answer. n equals 31. So that means it's the 31st sequence. T31 equals negative 117, correct. Okay. So find the number of terms. So you would say n is 31, so it's 31 terms is when it's going to be negative 117. Questions? Yeah, go for it. So just don't distribute, but I know you probably want to distribute. Don't go ahead and divide now. Okay? You can distribute. It'll still be fine, but a little more work, not too much. Okay, arithmetic means. Says the terms placed between two non-consecutive terms of the arithmetic sequence are called arithmetic means. For example, in the sequence 5, 10, 15, 20, the numbers 10 and 15 are arithmetic means between 5 and 20. So what they are, they're in between the values. Okay? So in order to determine arithmetic means between two given terms, it's helpful to think of it as a first and last term. So what happens is we're going to go -4. I'll show you what they're talking about. I know it sounds kind of confusing here, but if you do the problem, it makes more sense. -4, it says 3 arithmetic means between them. That just means 3 numbers that we don't know. Yeah. Okay. What we're going to do is that we are going to try to figure out these 3 terms. And what we want to think of these as is it doesn't tell us that -4 is the first term and a is the last term, but we can isolate it and say that it is for now. Because we can call this our a, okay, and we can call this our, what term would this be? 1, 2, 3, 4, the 5th, right? If I'm calling this 1, we don't know 2, 3, or 4, but we know 5 technically. So it's kind of like we're looking at our own window here. Because it doesn't matter where you start or finish, because arithmetic sequences, they all have the same pattern regardless of where you cut them, right? So what we're going to pretend is, we're going to say a is -4. We're going to say that t of 5 equals 8. Therefore, we're going to say n is 5. Why am I doing that? Because again, what are we missing? We're missing what the common difference is. So we're trying to solve for d. So when you look at everything we've been talking about, so it's going to be, we know the general is this. You can see I just found a way to get information for 3 out of 4. We want 3 out of 4 so we can solve. So I have a t sub n. T sub n is going to be 8. I have an a. It's going to be -4. I have an n. It's going to be 5. I don't know d. And so I'm going to solve for d now. Okay? Is everybody okay with that? Yep. Because we're going to say, so they told us -4 and 8, and there's 3 in the middle. So that means there's 5 spots here. So 5 is what 8 is equal to. So we're saying term 1 is -4, term 5 is 8. Okay, so here we go. 8 equals -4 plus 5 minus 1 times d. So now you can see we just solve. Add the 4. 12 equals 5 minus 1 is 4d. So d is 3. So now what it asks me to do is it wants me to place the 3 arithmetic means between them, and it wants me to fill those numbers in now. So I know it's going up by 3 every time. So what's the second number? Good, -1, 2, 5, 8. So we completed the pattern. Say we completed the pattern. All right, good. Okay, solving sequence problems where A and D are unknown. So when you have 2 missing variables, so back to math 10, what do you do when you have 2 variables that are missing? You got to do a little bit more of a system of equation, like you have to do a little bit more elimination or substitution type stuff. Okay? Oh my gosh. All right, so here's the deal. Consider the sequence x plus 2, 3x minus 1, and 2x plus 1. So what we want to do first is let's find the common difference. We can still do this. I know it's weird because it's variables. But what would we do normally? We would take the second one minus the first one, right? So if I go 3x minus 1, subtract x plus 2, 3x minus x is 2x. Negative 1 minus 2 is 3. So this right here, that's my common difference. Just stay with your same rules, even though it's weird. 2x minus 3 is my common difference for the first two. Okay, I'm going to do it for the second group too. I'm going to do it for these two. 2 minus 3 is negative 1. 1 minus a negative 1 is plus 1, so plus 2. So this is also equal to D. Can I solve for x here? How? Right, you equal them to each other. So what I did was, they told me the sequence, and they said determine the value of x from the arithmetic sequence. So they're telling me it's arithmetic. If it's arithmetic, we know the constants change the same. So what we did was, we said, okay, this one minus that one equals something. This one minus that one equals something. They are the same value. So now we're going to set them equal to each other and solve like Lucas said. So we're going to go 2x minus 3 equals negative x plus 2. Add x, add x. Okay, so we get 3x equals 5. So x is 5/3. So we solved for x there.
And then your class change.
And so what it says now is determine the numerical value of the three terms. So what it's doing now is we're just going to plug x in and get actually numbers. So we're going to do 5/3 plus 2, 3 times 5/3 minus 1, 2 times 5/3 plus 1. Okay? So let's do that first one. So 5/3 plus 2. Okay? Remember, 2 in terms of thirds. I'm going to keep saying stuff like this because I want people you guys to have me for a long time. You guys need to know what that means. 2 in terms of thirds. 6/3. It's going to be 11/3, yes. So 6/3 plus 5/3 is 11/3. So that first thing as a value is 11/3. Okay, number 2, 5/3 times 3 minus 1. Well, the nice part is, look at the 3's. 3's cancel. 5 minus 1, 4. And the third one, 2 times 5/3 is 10/3. 10/3 plus 1. 1 in terms of thirds is 3/3. You get 13/3. So if you're saying that doesn't look like a pattern, you're right. It doesn't because we simplified stuff. This is why it does though. We said that it's going to be a, let's see, it looks like the common difference is going to be 5/3. Right, so 4 minus 11/3, it's just going 11/3, 12/3, 13/3. So it's going up by a third every time. Okay, so if you want to write 14 as 12/3, you can. So you see the pattern, but it's 11/3, 12/3, 13/3. Okay, now, I know some of you guys are scratching your head for a Monday here, but listen, I know it looks confusing, like you're thinking, I thought you said 5/3 is the common difference. 5/3 is what x was in the common difference. Okay, so I know that's confusing, but the actual common difference, if we put the values in, it's going up 1/3 every time. Okay, so it's going up 1/3 when we actually put the numbers in. 5/3 is just what x was. It's an unknown value. Okay? All right, we're almost done with this one. Third and eighth terms of arithmetic sequence are 12 and negative 18 respectively. Use arithmetic means to determine the fifth term in the sequence. So this is what you do. Third, okay, so we got 1, 2, 3. So here's number 3. And 4, 5, 6, 7, 8. Number 8. They say 12 and negative 18. And what I'm telling you is disregard that they said it's the third and the eighth term. We're going to treat these as the first term and the 2, 3, 4, 5, sixth term. We're going to chop it off so we can make our own pattern out of it. Because we want to call 12 what? Why do we do that? Yeah, we want 12 to be our A. Okay, so we're going to go T sub 8. So this is the stuff we have. This is why we're doing it. Our A in this situation is 12. Our T sub 8 is negative 18. Our N is 18. Or sorry, 8. And now we're going to solve to figure out what D is so we can fill in those gaps. Okay? So when we do this here, we're going to go 12 plus, sorry, we got the equals first. We got the negative 18 is equal to 12 plus n minus 1, so that's 7 times d. Because, oh, you're right. It's going to be 6 for us, isn't it? We changed it. I kept the old one. Thanks. Sorry, it's 6, guys, because we changed it. My fault, my fault. Just going to say, I was just looking at that Gavin. I was like, that's not going to divide good. So we want to say that this is 5. 6 minus 1 is 5. N minus 1d. Okay, so minus a 12, you get negative 30. 5d, divide by 5, divide by 5, d is negative 6. Now this makes sense because notice 12 got smaller. So we expect our d to be what? Negative, because it's getting lower. So we feel good about negative 6. So you also can plug it in and hopefully it comes out cleanly. So 12 minus 6, 6. 6 minus 6, 0. 6 minus 6, negative 6. Negative 12 fits in perfectly. So we feel pretty good about that. It wants the 5th actual term of the sequence. So remember, the actual ones are down here. So the 5th term is 0. State the first term, a. So we got to go backwards a little bit. First term is 24. Common difference is negative 6. Complete the following. What's that look like? That looks like slope formula because these are linear. That is true. Okay. You also could go term 8 minus term 3. Okay, so what's term 8 and term 3? Negative 18 minus the 12. And then you can go 8 minus 3, which is 5. You could also do that to figure out how it's changing. Just kind of like using the slope idea, right? Think about like points. Yeah, way simpler than doing all the way out, yes. So that's how you can figure out the common difference faster for sure. Okay. What are they saying here? So they're saying is right in terms of A and D. So term 8, this is just like in terms of seeing the pattern, guys. So term 8, in terms of A and D, remember that's A plus 7D, right? 1 less, like we were doing in the beginning there, on that right side of that column investigation. And then the second one is minus A plus 2D. So then that's all going to be over 5. So check this out. A minus A goes away. 7 minus 2 is 5. D over 5. Just proving that that's the difference. When you do that, you'll get the difference. That happens every time. So like to Gavin's point, yes, this is much easier than doing the full solve that we've been doing. So if you're just trying to find the common difference, you can use that slope formula model of subtracting the outputs on top, the y's, right, over the x's, which is the term numbers on bottom. And that's what we're going to do for the formula there on part E. To find common difference, okay, for getting your common difference, okay, we think of it as T of Q, they just have Q here, that's a Q, I know my Q's aren't very good, minus T of P over Q minus P will get you the common difference. So the outputs subtracted over the inputs. We got one last one for this guy, and then we'll take a little short break. Yes. Gosh, thanks. All right, so this last one. Okay, so this is similar to what we already did. The third and 8th terms of the arithmetic sequence are 12, negative 18. That's one we just did. Use a system of linear equations to determine the values of the first term and common difference, hence determine the 5th term. So if you think about it in terms of a system, what we would do is, this is just kind of just to refresh your math 10. Okay, T8 we know is, again, we just wrote this, is A plus 7D. And we know that term 3 is a plus 2d. We know the output of the 8th term is negative 18. And we know the output of this one is 12. So go back to elimination. This is a 2. Go back to elimination. Remember, elimination is when you add or subtract systems to eliminate a variable. Notice my a's are the same sign, right? So this to me means I'm going to subtract these. And you're just going to see how quick this one goes too. A minus a cancels. 7 minus 2, 5d. Negative 8 minus 12, negative 30. Divide by 5, divide by 5. D again is negative 6. Okay, and so that's just using system of equations to solve for D as well. Because again, you got to think about these in terms of linear equations. They're two lines that are happening at constant terms. Okay, it also wants to know the first term, so we could do that again. We could plug in negative 6 and solve for the first term. So remember, we're trying to, they're wanting us to solve for A and D right now. Just like, again, in Math 10, you were solving for X and Y. Okay, so we just found the D. So we're going to plug this back. We'll put it right here, because that's a little bit easier one. A plus 2 times negative 6 equals 12. A minus 12 equals 12. A equals 24. My first term is 24. So that's us just using, again, system of equations to solve these as well, because they are linear equations. Okay, we'll stop there for the video.